Hello, in this lecture we'll find out the area of the green triangle. In the drawing we have triangle ABCD. We know that all the sides of triangle ABCD are equal to 4 units. DC equals to BC equals to AB equals to AD. They are all equal to 4 units. And inside the square we have this circle, and we know that the radius of this circle equal to 1 unit, and we want to find out the area of this green triangle that is also inside this square. So first of all, I will present to you a new rule, rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So I will read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if you have this circle and we have also tangent to this circle, this tangent AB is tangent to this circle at this point. We'll define the point of tangency as point M. And if the center of this circle is at this point, we will also define the center of this circle as point O. And from the center of the circle we will draw radius from point O to M. We join points O and M together by a straight line. OM is the radius of this circle, and as you can see here, the radius OM, it is drawn to the point of tangency. That is to say, it is drawn to point M, that is the point of tangency. Again, point M is the point of tangency. Of tangent AB with this circle. So as you can see in the drawing, the radius OM is drawn to the point of tangency, Therefore, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay, so whenever you have a radius, like in this drawing, that is drawn to the point of tendency, then the tangent, in this case it is tangent AB, will be perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, so a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tendency. This radius OM, is drawn to the point of tendency. Therefore, this angle, therefore the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay, so we actually can implement rule number 1 in our drawing. We will define the center of this circle as point O, and we will define the point of tendency of tangent DA with this circle as point M. As you can see in the drawing, the radius OM is the radius of this circle, and it is given us that the radius of this circle equals to 1 unit. And as you can see in the drawing, the radius OM is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent DA with this circle. Therefore, the tangent DA will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. We will define the point of tendency of tangent AB with this circle as point N. We will join points O and N together by a straight line. ON is the radius of this circle because of the fact that line segment ON starts from the center of the circle, that is to say from point O, and ends at point N, that is a point on the circle itself. Therefore, ON is the radius of the circle, that is to say it equals to 1 unit. And as you can see in the drawing, the radius ON, it is actually drawn to the point of tendency. That is to say, it is drawn to point N, that is the point of tendency. Therefore, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? As you have already know, all 4 angles inside a square are right angles. ABCD is a square. This angle, angle DAB, is 1 out of 4 angles of square ABCD. Therefore, this angle equals to 90 degrees. It is a right angle. Okay? In the next step, I will present to you a new rule, rule number 2. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. So I will read rule number 2 again. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. So we will focus on quadrilateral MOAN, this quadrilateral. In quadrilateral MOAN, the sum of its angles is equal to 360 degrees according to rule number 2. Therefore, which angles we have in quadrilateral MOAN? We have 1, 2, 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees. Plus this angle that we will define as angle X. So 270 degrees plus the size of angle X must be equal to 360 degrees according to rule number 2. Okay, so according to rule number 2, the sum of the 4 angles inside quadrilateral MOAN equals to 360 degrees, that is to say 270 degrees plus the size of angle X must be equal to 360 degrees. We will subtract from this equality 270 degrees, and we will get that the size of angle X, it is actually equals to 360 degrees minus 270 degrees is equal to 90 degrees. So angle X equals to 90 degrees. So we can change X by 90 degrees. So as you can see, in quadrilateral MOAN, we have 4 right angles. All of its angles are right angles. And we also have rule number 3. According to rule number 3, any quadrilateral that has four right angles must be at least a rectangle if not a square. So if not a square, it must be a rectangle. So I repeat on rule number 3 again. According to rule number 3, any quadrilateral that has four right angles must be at least a rectangle, if not a square. So, because of the fact that this quadrilateral MOAN has four right angles, we relate to it as a rectangle. Okay. So we will relate to quadrilateral MOAN as a rectangle. I will repeat again. We will relate to quadrilateral MOAN as a rectangle. So quadrilateral MOAN, this quadrilateral is a rectangle, and we also have new rule number 4. According to rule number 4, the opposite sides of a rectangle are equal to each other. I will write it down. The opposite sides of a rectangle are equal to each other. I will read rule number 4 again. Rule number 4 states that the opposite sides of a rectangle are equal to each other. So here in rectangle MOAN, this rectangle, according to rule number 4, MO equals to AN, I'll repeat again, according to rule number 4, in rectangle MOAN, MO is equal to AN, MO equal to AN, but we already know it is given us the question that MO equals to 1 unit, so we can write here that MO equals to 1 unit. So from this equality we will conclude that AN also equals to 1 unit. Here AN equals to 1 unit. Likewise, according to rule number 4, MA equals to ON. I'll repeat again, according to rule number 4, MA equals to ON. But we already know that ON equals to 1 unit. ON equals to 1 unit. So from this equality, we will conclude that AM or MA also equal to 1 minute. So we conclude from this equality that MA also equals to 1 unit. MA equals to 1 unit. So MA equals to 1 unit. So actually we found out that all 4 sides of quadrilateral MOAN, this quadrilateral, are equal to each other. They are all equal to 1 unit. And we already found out that all the sides of rectangle MOAN are right angles. All the angles are right angles. So we also have rule number 5. According to rule number 5, any quadrilateral that has four right angles and four equal sides must be a square. So I will read rule number 5 again. According to rule number 5, any quadrilateral that has four right angles and four equal sides must be a square. And this quadrilateral MOAN has four equal sides and four equal angles, therefore it is a square according to rule number 6. According to rule number 5, quadrilateral MOAN is a square. This quadrilateral is a square, and we also have rule number 6. According to rule number 6, the diagonals of a square bisect the angles of the square into 45 degrees angles. So I read rule number 6 again. According to rule number 6, the diagonals of a square bisect the angles of the square into 45 degrees angles. So in our square MOAN, according to rule number 6, the diagonal OA, this diagonal, bisects the angles of this square into 45 degrees angles. That is to say, if we relate to angle A, that is a right angle, this angle will be equal to 45 degrees, and this angle will be also equal to 45 degrees. Okay. this angle, it is actually angle OAN or OAB. Okay, this angle is angle OAB, and according to rule number 6, angle OAB equals to 45 degrees. I'll repeat again, because of the fact that this point is point N, is located on side AB of the square, it doesn't matter at all if we relate to this angle as angle MON or MAB, because of the fact that point N is located on AB. Okay? So this angle, we will call it as angle MAB, and angle MAB equals to 45 degrees according to rule number 6. So we got that angle OAB equals to 45 degrees according to rule number 6. Likewise, the diagonal CA of square ABCD it is so diagonal CA of square ABCD, this diagonal CA, according to rule number 6, the diagonal CA bisects this angle into 45 degrees angle. So this angle equals to 45 degrees. That is to say, angle CAB equals to 45 degrees. According to rule number 6, we'll write it down, angle CAB also equals to 45 degrees. According to rule number 6, I'll repeat again, angle CAB equals to 45 degrees according to rule number 6. So both angles, angle OAB and angle CAB, are both equal to 45 degrees, therefore they are equal to each other. So angle OAB equals to angle CAB, And because of the fact that angle OAB equals to angle CAB, we will conclude that the diagonal CA passes through point O. Okay, we conclude that the diagonal CA of square ABCD passes through point O. I repeat again, because of the fact that angle OAB equals to angle CAB, we will conclude that the diagonal CA of square ABCD passes from point O in the drawing. This diagonal CA of square ABCD passes from this point O. Okay. In the next step, I will present to you a new rule number 7. According to rule number 7, if a length of one side of a square is equal to S units, then the length of its diagonal will be equal to square root of 2 times S. Okay. So I will read rule number 7 again. According to rule number 7, if a length of one side of a square is equal to S units, then the length of its diagonal will be equal to square root of 2 times s. Okay, so what is the meaning of rule number 7? The meaning of rule number 7 is that if we have square ABCD, so in this square ABCD, we know that the length of its sides is equal to s units, so all the lengths of these square sides will be equal to s. So if we know that the length of the square sides is s units, like in this drawing, then the length of its diagonal, that is to say, the length of diagonal BC, diagonal BC, or it can be also, could be also diagonal AD. So the length of diagonal BC will be equal to square root of 2 times s. Okay. Again, if we know that the length of one side of square ABCD is equal to s units, like in this drawing, then the length of its diagonals, diagonal BC or diagonal AD, will be equal to s times square root of 2 units. Okay, so we find out the length of chord of diagonal OA in square MOAN. So in square MOAN, the length of diagonal AO, this diagonal, will be equal, according to rule number 7, to square root of 2 times the length of its side, that is actually 1 unit. Square root of 2 times 1 is square root of 2. So we found out that the length of diagonal OA in square MOAN equals to 2 units. So we can write here that OA equals to 2 units in its length. Likewise, if we relate to square ABCD, the big square ABCD, we know that one side of this square ABCD is equal to 4 units. Therefore, the length of its diagonal CA or AC the diagonal AC will be equal to 4 times square root of 2 units, okay? AC, the diagonal AC of square ABCD equals to 4 times square root of 2 units. And what is the length of line segment CO? So you can see from the drawing, the length of line segment CO will be equal to AC minus AO. Again, AC minus AO equals to OC. So I will write it down. The length of line segment OC, you can see it from the drawing, will be equal to AC, that is the length of square ABCD, that is the length of diagonal AC of square ABCD, minus OA, that is actually the diagonal of square MOAN. Okay, so we found out that OC equals to AC minus OA. But we have already found out that AC equals to 4 times square root of 2 units, minus OA, we've already found out that OA or AO equals to square root of 2 units. So in conclusion, we will get that 4 times square root of 2 units minus 1 times square root of 2 units equals to 3 times square root of 2 units. So we found out that OC equals to 3 times square root of 2 units. Okay, so we can write here that OC this line segment OC or CO equals to 3 times square root of 2 units. Okay? In the next step, we will define the touching point between tangent EC, the touching point between tangent EC and the circle. We will define the touching point as point K. Point K is also the point of tangency of tangent EC with this circle. I will repeat again. This point, point K, is the point of tangency of tangent EC with this circle. We will join together points O and K by a straight line. Line segment OK or KO is defined as the radius of this circle. Why it is the radius of this circle? Because of the fact that it starts from the center of the circle and ends at point K, that is the point of the circle itself. Therefore, OK or KO is the radius of this circle, that is to say it equals to 1 unit. And as you can see in the drawing, this radius, the radius OK or KO, it is drawn to the point of tangency, that is to say it is drawn to point K, that is the point of tangency of tangent EC with this circle. Therefore, according to rule number 1, this tangent EC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? So, in the next step, we will focus on the right triangle COK. Okay, we will focus on the right triangle COK. We will focus on the right blue triangle COK. On the right blue triangle COK, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the blue right triangle, it is CO. So the square of the hypotenuse is CO square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OK square plus CK square plus CK square. I repeat again, in the right blue triangle COK, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, CO squared, that is the square of the hypotenuse, equals to the sum of the squares of the perpendiculars equals to OK square plus CK square. We have already found out that CO equals to 3 times square root of 2 units. Therefore, CO square will be equal to 3 times square root of 2 square, and it equals to OK square. OK equals to 1. 1 square is 1 plus CK square. CK is the missing variable, so we will leave it as it is. So we actually found out that 3 times square root of 2 square equals to 1 plus CK square. 3 times square root of 2 square, it is actually 9 times 2. So I'll write it down. 9 times 2 equals to 1 plus CK square. Here 9 times 2 is 18, so I write it down. 18 equals to 1 plus ck squared. So here we will subtract 1 from this equation number 1, and we will get that 18 minus 1 is 17. 17 equals to ck squared. So here we'll take a root out of equation number 1, and we will get that ck equals to the square root of 17. So I found out that according to equation number 1, ck equals to the square root of 17 units. So we can write here that ck equals to the square root of 17 units. In the next step, we will calculate the value of side EB of the green triangle. We will calculate the value of line segment EB or side EB. EB, from the drawing you can see that EB equals to AB minus AN minus NE. I will repeat again, EB, line segment EB equals to AB minus AN minus NA. Okay? EB equals to AB minus AN minus NA. Very simple, you can see it from the drawing. So EB equals to AB minus AN minus NE. Okay, so EB equals to AB equals to 4 units because it is one side of square ABCD and all sides of square ABCD are equal to 4 units. So AB equals to 4 units minus AN. We have already found out that AN equals to 1 unit. Minus EN minus NE so in total, in conclusion, we found out that AB equals to 4 minus 1 minus NE. 4 minus 1 is 3, so in conclusion we found that EB equals to 3 minus NE. EB equals to 3 minus NE. So in the next step I will present to you a new rule, the last rule, rule number 8. According to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So I will repeat on rule number 1 again, rule number 8 again. Rule number 8 states that the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 8? The meaning of rule number 8 is that if we have this circle and we also have this external point, point P. Why point P is an external point? Because point P is not located inside this angle, inside this circle, nor on this circle, but is located outside of this circle. Therefore, point P is defined as an external point. So if from the external point, point P, we will draw two tangents to this circle, so the first tangent will be we will define the point of tangency of the first tangent with this circle as point A, and we will also draw a second tangent to this circle from point P. This will be the second tangent to this circle. We will define the touching point or the point of tangency of this second tangent with the circle as point B. So actually the length of the first tangent, this tangent, is PA, and the length of the second tangent is PB, and according to rule number 8, the lengths of those two tangents that are from the external point P to that circle will be equal to each other. That is to say, PA equals to PB. Okay? I will repeat again on rule number 8, the lengths of two tangents, that is to say, this is the first tangent, this is the second tangent, from a common external point to a circle are equal. Point P is an external point, and it is actually a common external point. So we draw two tangents from the common external point P to this circle, and according to rule number 8, the lengths of those two tangents will be equal to each other. That is to say, PA equals to PB. Okay, so whenever you draw from a common external point two tangents to a circle, then the lengths of those two tangents will be equal to each other. In this drawing, it means that PA equals to PB. Okay, so that is the main rule number 8. We can actually implement rule number 8 in our drawing, because in our drawing we have the common external point, point E. From the common external point, point E, we have two tangents to this circle. The first tangent is EN. The second tangent is EK. And according to rule number 8, because we have two tangents from the common external point E, then the length of those two tangents will be equal to each other. That is to say, EN equals to EK according to rule number 8. Okay, so according to rule number 8, the length of the two tangents will be equal to each other. That is to say, EN equals to EK. And if we define En as x, En equals to x according to our definition, then Ek will be also equal to x because of the fact that they are equal to each other. So here we get that En equals to x and En equals to x equals to Ek. From here we can see that we can derive that Ek also equals to x. So actually here we found out that EB equals to 3 minus NE or En, and we defined En as x, so in conclusion EB will be equal to 3 minus x. So we can write here that EB equals to 3 minus x. And we know that all four angles inside the square are right angles. This angle CBA or ABC, is one out of four angles of square ABCD. Therefore, it will be equal to 90 degrees. So if this angle ABC equals to 90 degrees, then the green triangle will be a right triangle. So triangle CBE is a right triangle. We will focus on the right triangle, triangle CBE. And on the right triangle, triangle CBE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this green right triangle is CE. If the hypotenuse is CE, then the square of the hypotenuse will be equal to CE squared. and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to EB square. It equals to EB square plus CB square. Actually, CB is one side of square ABCD, therefore it equals to 4 units because all the 4 sides of square ABCD are equal to each other and they are equal to 4 units. It is given us in the question. AD equals to 4. Okay, so PC will be also equal to 4 units. So we got that according to the Pythagoras theorem, in the right green triangle, triangle CBE, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. That is to say, CE square equals to EB square plus CB square. And CE what is the value of CE? CE equals to square root of 17 plus x. Therefore, CE square will be equal to the square root of 17 plus x squared. EB, as you can see from the drawing, EB equals to 3 minus x. Therefore, EB square will be equal to 3 minus x squared plus CB square. So you can see here CB equals to 4 units, so CB square is 4 square. 4 square is 16. So in conclusion, we found out that square root of 17 plus x square equals to 3 minus x square plus 16. Here we will open the brackets of equation number 2 from both sides of the equation, and we will get that square root of 17 plus x square, it equals to 17 plus x square plus 2 times square root of 17 x, and it equals to 3 minus x square. 3 minus x square equals to 9 plus x square minus 6x plus 16. Here we have x square on both sides of equation number 2, so x square will get cancelled. And here 16 plus 9 is 25, so I write it down. In this side of the equation we left only with 25 minus 6x, and here we have 17 plus 2 times square root of 17 x here we will subtract from this equation number 2 17, and we will get that 2 times square root of 17x equals to 25 minus 17 is 8 minus 6x. So here we divide this equation number 2 by 2, and we will get that here 2 over 2 is 1. So we get here square root of 17 times x equals to 8 over 2 is 4, minus 6 over 2 is minus 3x. So in conclusion, we got that according to equation number 2, square root of 17 times x equals to 4 minus 3x. Here we will add to this equation, equation number 2, 3x, and we will get that square root of 17 x plus 3x equals to 4. Here we will take a common factor from these two expressions. The common factor that we will take will be x. So what is left from square root of 17x after we took from it x as a common factor? What is left, it is actually square root of 17. And what is left from 3x after we took from it x as a common factor? What is left, it is actually 3. And it equals to 4. So here we will divide this equation, equation number 2, by square root of 17 plus 3, and we will get that x equals to 4 over square root of 17 plus 3. So here we will multiply this side of equation number 2 by square root of 17 minus 3, and then we will divide it by square root of 17 minus 3 in order to get rid from the denominator. We don't like that we have square root in the denominator, so by multiplying both sides of this this side of equation number 2 by square root of 17 minus 3, we will get rid from the square root that we have in the denominator. So we will do it now. X will be equal to 4 over square root of 17 plus 3, and then we will multiply the numerator by square root of 17 minus 3, and then we will divide it by square root of 17 minus 3. So we have square root of 17 plus 3 times square root of 17 minus 3. We will use the algebraic identity that a plus b times a minus b equals to a square minus b square. We'll use this algebraic identity to find out the value of this expression. So here a will be equal to square root of 17 and b will be equal to 3. And according to the algebraic identity, a plus b, a minus b equals to a square minus b square. A square is square root of 17 square is 17. Minus b square. B is 3, so b square is 3 square. 3 square is 9. So in total, or in conclusion, in the denominator, we got only 17 minus 9. We didn't touch on the numerator, so we will leave it as it is. It remains as it is because we didn't touch it. It is 4 times square root of 17 minus 3, and it equals to x. So in conclusion, we got this expression that x equals to 4 times square root of 17 minus 3 over 17 minus 9. 17 minus 9 is 8, so I'll write it down. In conclusion, we will get that according to equation number 3, according to equation number 2, x equals to 4 times square root of 17 minus 3 over 8, because 17 minus 9 is 8. Here we will divide the numerator and the denominator on this side of equation number 2 by 4. 4 over 4 is 1, so 4 will get cancelled, and 8 over 4 is 2. So in conclusion, we will get that x equals to square root of 17 minus 3 over 2. So we found out the value of x. X equals to square root of 17 minus 3 over 2. And what is the area of the green triangle? The green triangle is a right triangle, and the formula for the area of any triangle, it is actually equals to the base of the triangle times the height to the base over 2. Okay, we use this formula in order to calculate the value of the green right triangle, triangle CBE. Okay, so according to this formula, the base of this green right triangle is EB. The height of this green right triangle is BC. Over 2. So the area of triangle CBE so actually this is the sign of the area of triangle. It means the area of triangle CBE, it will be equal to EB times BC over 2. And what is the value of EB? So you can see EB equals to 4 minus x. Three minus x. EB equals to 3 minus x. BC equals to 4 units. Over 2. So, in conclusion, we found out that the area of the green right triangle CBE, so this is the sign of the area. The area of the green right triangle CBE equals to 3 minus x times 4 over 2. 4 over 2 is 2, so I'll write it down. So the area of the green right triangle CBE equals to 2 times 3 minus x. I'll repeat again, the area of the green right triangle CBE equals to 2 times 3 minus x. But we have already found out that according to equation number 2, the value of x is actually square root of 17 minus 3 over 2. Okay, so here we will place the value of x in this equation number 3, and we will get that the area of the green right triangle CBE, according to equation number 3, equals to 2 times 3 minus x, and according to equation number 2, x equals to square root of 17 minus 3 over 2. Okay, the area of the green right triangle CBE equals to 2 times 3 minus square root of 17 minus 3 over 2. Here we will open the brackets on this side of equation number 3, and we will get that the area of the green right triangle CBE, according to equation number 3, it equals to 2 times 3 is 6, and we have here minus before the brackets, so this will be 2 over 2 is 1, so 2 will get cancelled. So it is actually 2 over 2 is 1, so 2 will get cancelled, and in conclusion, what is left, it is actually minus square root of 17 minus 3 so the area of the green right triangle CBE equals to 6 minus square root of 17 and minus 3 is plus 3. So in conclusion, the area of the green right triangle CBE, according to equation number 3, it equals to 9 minus square root of 17 square units, or in terms of numbers, it equals to 4.88 square units. I will repeat again, the area of the green right triangle CBE equals to either 9 minus square root of 17 square units, or in terms of numbers, the area of the green right triangle CBE equals to 4.88 square units. You can see it in the drawing itself. That the area of this green right triangle CBE equals to either 9 minus square root of 17 square units, or in terms of numbers, the area of this green right triangle CBE equals to 4.88 square units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the area of this green triangle CBE. And we have here square ABCD. We know that one side of square ABCD equals to 4 units. And inside this square we have this circle. The radius of this circle equals to 1 unit. Inside this square ABCD we also have the green triangle, and we want to find out the area of this green right triangle. So first of all, I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if you have this circle and we have tangent AB is tangent to this circle at point M. Point M is the point of tangency of tangent AB with this circle. The center of this circle is at this point O. We draw radius to this of the circle OM is the radius that is actually drawn to the point of tangency. That is to say, it is drawn to point M, that is the point of tangency of tangent AB with this circle. Therefore, according to rule number 1, the tangent AB will be perpendicular to this radius. Again, a tangent to a circle, that is to say AB, is perpendicular to the radius drawn to its point of tangency. So whenever you have a radius, like in this drawing, that is drawn to the point of tangency, then the tangent will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? Then we implemented rule number 1 in our drawing. We have this radius that is drawn to the point of tangency, that is to say, it is drawn to point M, that is the point of tangency of tangent AD with this circle. Therefore, according to rule number 1, the tangent AB will be perpendicular to this radius. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. And we also know that all four angles inside, all the four angles inside the square are right angles. This angle is one out of four angles of square ABCD, therefore it equals to 90 degrees. And we have here this radius, it is round to the point of tendency, that is to say it is round to point N, that is the point of tendency of tangent AB with this circle. Therefore, the tangent AB will be perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle equals to 90 degrees. And we also connected points O and K together by straight line. Point K is the point of tendency of tangent EC with this circle. OK is the radius of this circle. Why OK is the radius of the circle? Because of the fact that it starts from point O, that is the center of this circle, and ends at point K, that is the point on the circle itself. Therefore, OK is defined as the radius of this circle. And this radius, OK, it is drawn to the point of tendency, that is to say it is drawn to point K, that is the point of tendency. Therefore, the tangent EC will be perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule number 1. And I also presented to you rule number 2. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. So we will focus on quadrilateral MOAN. This quadrilateral MOAN. What is the sum of the angles in quadrilateral MOAN? According to rule number 2, it equals to 360 degrees. So which angles it contains? It has three right angles, 1, 2, 3. And the sum of three right angles is equals to 270 degrees. Plus the size of this angle that we defined as angle X must be equal to 360 degrees according to rule number 2. I will repeat again, the sum of the three angles, that is 270 degrees, plus the size of the fourth angle must be equal to 360 degrees according to rule number 2, this rule. So we subtracted 270 degrees from this equality, and we got that the value of angle X is 90 degrees, that is to say it is a right angle. So we replaced F by 90 degrees because X equals to 90 degrees. So we found out that all four angles inside quadrilateral MOAN are right angles. And we also have rule number 3. According to rule number 3, any quadrilateral that has four right angles must be at least a rectangle if not a square. So we found out that quadrilateral MOAN, this quadrilateral, it has four right angles. Therefore, according to rule number 3, it must be at least a rectangle. So we will relate to quadrilateral MOAN as a rectangle because it has four right angles, and according to rule number 3, it must be at least a rectangle. Okay? Then we have also rule number 4. Rule number 4 states that the opposite sides of a rectangle are equal to each other. So MOAN is a quadrilateral, therefore its opposite sides are equal to each other. That is to say, MO equals to AN according to rule number 4. MO equals to AN according to rule number 4. Okay? What we know, it is given us the question that MO equals to 1 unit. MO equals to 1 unit. MO equals to 1 unit. So from this equality, we will conclude that AN also equals to 1 unit. AN equals to 1 unit. Likewise, AM, that is the opposite sides to ON, will be equal to ON according to rule number 4. AM equals to ON according to rule number 4. But we have already found out that ON equals to 1 unit. ON equals to 1 unit. So from this equality we will conclude that AM also equals to 1 unit. Here AM or MA equals to 1 unit. So we actually found out that all 4 sides of rectangle MOAN are equal to each other. They are all equal to 1 unit. And all of its 4 angles, they are right angles, therefore they are equal to each other. And we also have rule number 5. According to rule number 5, any quadrilateral that has 4 right angles and 4 equal sides must be a square. So here quadrilateral MOAN has 4 right angles, 1, 2, 3, 4, and 4 equal sides. Therefore, according to rule number 5, quadrilateral MOAN is a square. And we also have rule number 6. According to rule number 6, the diagonals of a square bisects the angle of the square into 45 degrees angles. So the diagonal OA in square MOAN bisects its angles into 45 degrees angles. So if you relate to this angle, the diagonal OA bisects this angle into 2 angles of 45 degrees. So this angle will be equal to 45 degrees, and this angle OAN will be also equal to 45 degrees. But because of the fact that point N is located on AB, that is to say points A, N, and B are located on one straight line, it doesn't matter at all if we call to this angle OAN or angle OAB, because of the fact that points A, N, and B are located on one straight line. Okay, so we will relate to this angle as angle OAB. Okay, so angle OAB equals to 45 degrees. According to rule number 6, angle OAB equals to 45 degrees according to rule number 6. Likewise, the diagonal CA of the big square bisects its angles into 45 degrees angles. That is to say, this angle equals to 90 degrees and this angle also equals to 45 degrees. That is to say, angle CAB will be also equals to 45 degrees according to rule number 6. Angle CAB also equals to 45 degrees according to rule number 6. So you can see both those two angles are equal to 45 degrees, therefore they are equal to each other. That is to say, angle OAB equals to angle CAB. I'll repeat here, in the drawing, angle OAB, this angle, equals to angle CAB, this angle CAB. So because of the fact that those two angles are equal to each other, we conclude that the diagonal CA of square ABCD passes through point O. Okay, diagonal CA of square ABCD passes through point O. Otherwise, if diagonal CA doesn't pass through point O, then it is impossible that angle CAB will be equal to angle OAB. It cannot possible that angle CAB will be equal to angle OAB. They must be points, the points C, O, and A must be on the same straight line in order that angle CAB will be equal to angle OAB. Otherwise, if points C, O, and A are not located on the same straight line, then angle CAB will never be equal to angle OAB, but because of the fact that those two angles are equal to each other, we will conclude that the diagonal CA passes through point O. It means that the 3 points C, O, and A are located on one straight line. Okay? Then I presented to you rule number 7. According to rule number 7, if a length of one side of a square is equal to S units, then the length of its diagonal will be equal to square root of 2 times S. I will repeat again. If a length of one side of a square is equal to S units, then the length of its diagonal will be equal to square root of 2 times S. Okay, so what is the meaning of rule number 8? The meaning of rule number 8 is that if you have this square ABCD, and we know that the length of one side of this square ABCD is equals to S units, then the length of its diagonals, that is to say the length of diagonal CB or diagonal DA, it doesn't matter, they are equal to each other. So the length of diagonal BC will be equal to square root of 2 times the length of one side of square ABCD, that is actually S. So if the length of the side of a square are equal to S, then the length of its diagonal will be equal to 2 times, to square root of 2 times S, or square root of 2 multiplied by S. And we implemented this rule number 7, in order to find out the length of diagonal AO. In square OMAN, we have diagonal OA. The length of diagonal OA, according to rule number 7, will be equal to the length of its side, that is 1 unit, times square root of 2. Okay, square root of 2 times 1, that is actually square root of 2 units. So we found out that the length of diagonal OA equals to square root of 2 units. Likewise, in square ABCD, we have the diagonal AC or CA, and according to rule number 7, the length of diagonal CA will be equal to the length of its sides, the length of square ABCD sides, that is actually 4 units, times square root of 2. So we found out that AC, the length of square ABC, the length of diagonal AC, that is the diagonal of square ABCD, equals to 4 times square root of 2 units. Okay, so in conclusion, we found out that OA, that is the length of the diagonal of square OAN, equals to 2 units, and the length of AC, that is the diagonal of square ABCD, equals to 4 times square root of 2 units. Okay? Then we found out the value of line segment OC. OC equals to AC minus OA, as you can see here. AC minus OA equals exactly to OC. Again, AC minus OA equals to OC. OC equals to AC minus OA. So OC equals to AC is 4 times square root of 2 units, and AO is square root of 2 units. 4 times square root of 2 units minus 1 times square root of 2 units equals to 3 times square root of 2 units. So in conclusion, we found out that OC equals to 3 times square root of 2 units. So here we can write down that OC equals to 3 times square root of 2 units. Okay, then we actually implemented the Pythagoras theorem in the green in the blue right triangle, triangle COK. According to the Pythagoras theorem, in the right green triangle COK, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the blue right triangle, it is actually CO. So the square of the hypotenuse is CO square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OK square plus KC square. It equals to OK square plus CK square. CO equals to 3 times square root of 2 units. So CO square will be equal to 3 times square root of 2 units square. And it equals to OK square. OK equals to 1. OK square is 1 square. 1 square is 1. Plus CK square. CK is the missing variable, so we leave it as it is. Here, 3 times square root of 2 square equals to 9 times 2, because 3 square is 9, and the square root of 2 equals to 2. So here we have 1 plus CK square. 9 times 2 is 18. 18 equals to 1 plus CK square. We subtracted 1 from this equation, equation number 1. 18 minus 1 is 17. 17 equals to CK square. We took a root out of equation number 1 and we found out that CK equals to the square root of 17. So here, CK or KC equals to the square root of 17. Then we calculated the value of line segment EB. What is the value of EB? You can see from the drawing that EB equals to AB minus AN minus EN. If you subtract from AB, AN and EN, you will get EB. So EB equals to AB minus AN minus EN. AB equals to 4 units. There is the one side of square ABCD. AN equals to 1 unit. AN equals to 1 unit. Minus NE. So, in conclusion, we found out that EB equals to 4 minus 1, 4 minus 1 minus NE. That is to say, EN equals to 3 minus NE. Okay? Then, I presented to you rule number 8. According to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 8? The meaning of rule number 8 is that if you have this circle and we have the external point, point P, and from the external point P, we will draw two tangents to this circle. The first tangent is PA. The point of tangency of tangent PA with this circle is point A. And we draw the second tangent, tangent PB. The point of tangency of the second tangent with this circle is point B. So according to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So the length of the first tangent is PA. The length of the second tangent is PB. And according to rule number 8, whenever you draw from a common external point to a circle two tangents, to that circle, then the length of those two tangents will be equal to each other. In this case, PA will be equal to PB. Okay, so that is the meaning of rule number 8. We implemented rule number 8 in our drawing. In our drawing, we have the common external point, point E. And from point E, we have two tangents to this circle. The first tangent is tangent EK, and the second tangent is tangent EN. And according to rule number 8, the length of those two tangents will be equal to each other. That is to say, EN equals to EK. EN equals to EK according to rule number 8. We defined EN as X. So if En equals to x, so from this equality we conclude that Ek also equals to x. Okay, so Ek also equals to x, and EB equals to, we found out that EB equals to 3 minus NE, and NE equals to x. NE equals to x, so we substituted NE by x, and we got that line segment EB equals to 3 minus x. So we found out that line segment EB equals to 3 minus x. Here we can write down that EB equals to 3 minus x, and we know that BC, it is one side of square ABCD, therefore it equals to 4 units, and we already found out that EC equals to square root of 17 plus x units, so we focus on the right green triangle, triangle CBE. Why the green triangle is the right triangle? Because this angle is 1 out of 4 angles of square ABCD, therefore it is a right angle because all the 4 angles inside the square are right angles. So this angle is a right angle, therefore the green triangle, triangle CBE, is a right triangle. So we implemented the Pythagoras theorem in the right green triangle, triangle CBE. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is CE, therefore the square of the hypotenuse is CE square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to EB square plus CB square. So in conclusion, we found out that CE square equals to EB square plus CB square. CE equals to square root of 17 plus x, so CE square will be equal to square root of 17 plus x square. EB equals to 3 minus x, so EB square will be equal to 3 minus x square. CB equals to 4 units, so CB square will be equal to 4 square. 4 square is 16. We open the brackets on both sides of this equation, equation number 2, and we got that the square root of 17 plus x square equals to 17 plus x square plus 2 times square root of 17x, and 3 minus x square equals to 9 plus x square minus 6x plus 16. We have x square on both sides of equation number 2, so x square will get cancelled. And what is left after we cancel x square from equation number 2? What is left is actually 17 plus 2 times square root of 17x equals to 25 minus x. So here we know that 9 plus 16 is 25. So here what we got from here, this side of equation number 2 is 25 minus 6x, and here we have only 17 plus 2 times square root of 17x. Here we subtracted 17 from this side, from equation number 2. So 17 minus 17 is 0, and 25 minus 17 is 8. So in conclusion, we got that 2 times square root of 17x equals to 8 minus 6x. We divided equation number 2 by 2, and we got that 2 over 2 is 1, so here what is left is actually square root of 17x. 8 over 2 is 4, and minus 6 over 2 is minus 3x. Minus 6x over 2 is minus 3x. So in conclusion, we got that square root of 17x equals to 4 minus 3x. We added 3x to this equation, equation number 2, and we got that square root of 17x plus 3x equals to 4. Here we took a common factor x from these expressions, and here we have x as a common factor, so what is left from square root of 17x after we took from it x as a common factor? What is left is actually square root of 17 And what is left from 3x after we took from it x as a common factor, what is left, it is actually 3. So in conclusion, we got that x times square root of 17 plus 3 equals to 4. We divided this equation number 2 by square root of 17 plus 3, and we got that x equals to 4 over square root of 17 plus 3. Here we multiply this side of equation number 2 by square root of 17 minus 3, and then we divided it by square root of 17 minus 3. So in the numerator we have 3 times square root of 17 minus 3, and in the denominator we have square root of 17 plus 3 times square root of 17 minus 3. So we found out the value of this expression by using the algebraic identity that a plus b times a minus b equals to a square minus b square. Here in our specific case we have a equals to square root of 17 and b equals to 3. So it equals to a square minus b square. A square is square root of 17 square is 17, and b equals to 3, so b square is 3 square is 9, so in conclusion we got the denominator 17 minus 9, and we didn't touch in the numerator, we didn't touch the numerator, so it remains as it was. That is to say, it remains as 4 times square root of 17 minus 3. 17 minus 9 is 8, so we have 8 in the denominator. So in conclusion, we found out that x equals to square root of 17 minus 3 over 8. We divided this side of equation number 2 by 4. 4 over 4 is 1 and 8 over 4 is 2. So in conclusion, we got that x equals to square root of 17 minus 3 over 2. So we found out the value of x. The value of x is actually square root of 17 minus 3 over 2. And we want to find out the area of the green right triangle, triangle CEB, and the general formula for the area of any triangle, it is actually the base times the height to the base over 2. The base in the green right triangle, triangle CBE, is EB, and the height is BC. So the base is EB and the height is BC. So in conclusion, we got that EB times BC over 2 is the area of the green right triangle, triangle CBE. Okay. Again, the area of the green right triangle, triangle CBE, this is the sign of the area. It means the area of triangle CBE. It equals to EB times BC over 2. EB equals to 3 minus x and BC equals to 4. So we found out that the area of the green right triangle, triangle CBE equals to 3 minus x times 4 over 2. 4 over 2 is 2, so in conclusion we found out that the area of the green right triangle CBE equals to 2 times 3 minus x. And because 4 over 2 is 2, so in conclusion we got that the area of triangle CBE equals to 2 times 3 over x. And we have already found out that according to equation number 2, x equals to square root of 17 minus 3 over 2. So we place the value of x inside x in this equation number 3, and we got that the area of the green right triangle CB equals to 2 times 3 minus x equals to square root of 17 minus 3 over 2. So we open the brackets in this side of equation number 3. 2 times 3 is 6. And here we have 2 times 2 is 1. Okay, 2 times 3 is 6 and 2 times 2 is 1, so 2 will get cancelled and we left only with square root of 17 minus 3. So in conclusion, the area of the green right triangle, triangle CBE equals to 6 minus square root of 17 minus 3. So we open the brackets in this side of equation number 3 and we got that the area of the green right triangle, triangle CBE equals to 6 minus square root of 17 and minus 3 is plus 3. Minus 3 is plus 3. So in conclusion we got that the area of the green right triangle, triangle CBE equals to 6 plus 3, that is 9, minus square root of 17 square units. I'll repeat again, the area of the green right triangle CBE equals to either 9 minus square root of 17 square units, or in terms of numbers, the area of the green right triangle CBE equals to 4.88 square units. I will repeat again, the area of this green right triangle CBE equals to either 9 minus square root of 17 square units, or in terms of numbers, the area of this green right triangle equals to 4.88 square units. Okay, thank you very much.